Hello. Starting a stream. So surprise stream just to uh, learn a little bit more Rust um, because I don't know that much Rust. So I'm going to go through these 20 chapters on Rust on Saturday and Sunday. And we'll see how fast I can do this. Hopefully I can do it super fast, and so won't have to worry too much. The Rust programming language. So let's see, installation. I already have mine installed, so I don't think I need to mess with this. But let's just double check that. Rust C version. Yep. Hello world. Okay. Now that you've installed Rust, let's write our first Rust program. It's traditional when learning a new language to write a little program that prints the text hello world in the screen, so we'll do the same here. Excuse me, I had to burp. Note the book assumes basic familiarity with command line. Rust makes no specific demands about your editing or tooling or your code lives, so if you prefer to use an integrated development environment instead of the command line, feel free to use your favorite IDE. Many IDEs now have some degree of Rust support. Check the IDE documentation for details. Recently, the Rust team has been focusing on enabling great IDE support, and progress has been rapid on that front. Okay. Create a directory. All right. Well, create a directory. So how should I do this? If I'm going to have an IDE, oops, I went to the next one, and this at the same time. There. That works. Okay. Yeah. Okay. Create a directory. You'll start by making a directory to store your Rust code. It doesn't matter to Rust where your code lives, but for the exercise and projects in this book, we may suggest making a projects directory in your home directory and keeping it there for your projects. Okay. Yeah, so let's make a directory and call it Rust underscore projects. CD Rust. Oh my god. I really hate the Windows command line. It's just not as good as Mac. Like when you do stuff like this and you get like a sorry about that really loud beep. When you do things like that and you get like a when you get a hidden folder, it's like I don't want to go into that hidden folder. Get out of here, Windows. I don't know. Maybe I'm just stupid. Okay, so let's make the hello world directory. Make hello world cd hello world, and if you're wondering how I'm typing the rest of the words without typing them, I'm just hitting the tab button, which is pretty much universal for every programming language, pretty much. Or not programming language, I mean command line, right? If you hit tab, it'll autofill the next file name. Okay, and so I don't know how to make a file in touch main.rs. No, touch isn't make. I don't know, main.rs. How do I make a? Hold on. Make file command line Windows. As I've never had to do that before. Let's just echo some text. Okay, is that really it? But I don't want to do that. I want to um, I don't want to do this. This is why Windows suck. Um, I would like to make a file and then vim into I guess I'm not going to be able to do that. So, let's just keep it simple. Let's open up Atom, lightweight thing, new file, and I can just, oh my god, accidentally closed it. Okay. And what does this want me to do? It wants me to, yeah. Okay, so this is like a lot of low-level languages. So I think in Rust they use four spaces instead of a tab, and I believe this is what they call a macro. This is just the initial opening of the function, and I have to get used to this semicolon at the end, and then I'll just save in my Rust projects. Hello world, save. Oh, right. Save it as main.rs. And that should be good. Okay. And then save the file, go back to terminal, do rust c main.rs. And then you do main.exe. Oops. I think I can just main.exe, right? Hello world. Awesome. Yeah. So, regardless of your operating system, the string hello world should print in your terminal. If you don't see the output, refer to troubleshooting part of the installation section for ways to get help. If hello world did print, congratulations, you have officially written a Rust program that makes you a Rust programmer. Welcome. Awesome. Officially a Rust programmer. I will put this in my resume. Anatomy of Rust. Okay, let's review the details, what just happened in your Hello World program. Here's the first piece of the puzzle. Main, function main. Okay, yep. These lines define a function in Rust. The main function is special. It's always the first code that runs in every executable Rust program. The first line declares the function name main and has no parameters and returns nothing. If there were parameters, they would go inside of parentheses. Also note, that the function body is wrapped in curly braces, curly brackets. Rust requires these around all function bodies. It's a good style to place the open curly bracket on the same line as the function declaration, adding one space in between. If you want to stick to the standard style across Rust projects, you can use an automatic formatter tool called Rust Format to format your code in a particular style. The Rust team has included this tool with the standard Rust distribution like Rust C, so it should already be installed on your computer. Check the online documentation for more details. Inside the main function of the following code, print hello world. Print line bang hello world. Some people call that bang, right? This line does all the work in this little program. It prints text to the screen. Here are the four important details to notice here. First, Rust style is to intent with four spaces, not tab. Second, print line bang calls a Rust macro if it's called a function. It's officially a kitty string. Kitty. Meow, 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 meow. Okay. Okay, so if it's called a function, it's called a macro. it called a function instead, it would be entered as print line parentheses without the bang. We'll discuss Rust macros in more detail in chapter 19. For now, you just need to know that using a bang means that you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. So one interesting thing that I noticed in the near documentation is that they referred to the brackets above a function as a macro as well. So I am interested in learning about that differentiation, if there's a difference between the function wrapping something in a function with bang, or just putting it at the top with the brackets. But yeah. Third, you see the hello world string. We pass the string as an argument to print line bang, and the string is printed to the screen. Yeah, right there. Fourth, we end the line with a semicolon. I'm going to have to get used to this. I program mostly in Python, so semicolon, ending any indication that you're at the end of your function. It's basically like if you unindent, that means your function's over or whatever. So this is weird for me, which indicates that this expression is over and the next one is ready to begin. Most lines in Rust code end with a semicolon. Compile and Rust running are separate steps. So yeah, we just experienced that. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering rustc command and passing it the name of your source file like this. Yep. Okay. If you have C or C++ background, you'll notice that this is similar to GC or C lang. After compiling successfully, Rust outputs a binary executable. I hate both of these. I've done a little bit of C and C++ in college, and I am not a fan of GCC or C lang, and I have the Windows compatible or whatever equivalent, and I feel like it never works. I am just so I feel like I have to troubleshoot these things so often that it's just really annoying. So I'm glad I'm learning something else. So let's see here. I'm going to minimize this window a little bit because I have a 1440 by 3440 screen, or wherever the resolution is, and if I keep reading, you might not see the bottom of this screen here. So I'll just make this a lot smaller, I guess. Okay. Okay, so where was I? Okay, Rusty. Yep. On Linux, Mac, and PowerShell on Windows, you can see the executable by entering ls. That's funny that they have to specify PowerShell on Windows because you can't use ls in the normal command prompt on Windows. You have to use the mkdir. Oops, no, I mean dir to see. Just FYI. On Linux and Mac OS, you'll see two files with PowerShell. On Windows, you'll see the same three files that you would see using CMD. Okay. With CMD on Windows, you have to enter the following. I wouldn't enter that. The B option says only show the file names. Oh, okay. I've never done that before. Wow. I guess that's a lot cleaner, and that's more like the Linux experience. So maybe I should start doing that. This shows the source code of the file with the rs extension, the executable on Windows, but main on the other platforms. And when using Windows, a file containing debugging information with the pdb extension. From here, you can run the main or main.exe file like this. If main rs was your hello world program, this line would print hello world to your terminal. If you're more familiar with a dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is a ahead-of-time compiled language, meaning you can compile a program and give the executable to someone else, and they can run it even without having Rust installed. If you give someone a .ruby or .python or .js file, they need to have Ruby, Python, or JavaScript implementation installed respectively. Both in those languages, you only need one command to compile and run your program. Everything is a trade-off in language design. Just compiling with Rust C is fine for simple programs, but as your projects grow, you'll want to manage all the options and make it easy to share your code. Next, we'll introduce you to Cargo tool, which will help you to write real-world Rust programs. Okay, check out Cargo. Whew. Okay, Cargo is a Rust build system and package manager. Most Rustaceans use the tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. The simplest Rust programs, like the ones we've written so far, don't have dependencies. So if we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installer discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by entering the following in your terminal. If you see a version number, you have it. If you see an error such as command not found, look at the documentation for your method of installation. Yeah, okay. Creating a project with Cargo. All right, so I guess we do this. All right, so let's cd dot, and then I will cargo new. Cargo new. Hello, Cargo. Cd hello cargo. The first command created a new directory called hello cargo. Yes, good. That's what I wanted. Okay, so this actually goes down to this little penguin icon. Okay. First command created directory called hello cargo. We've named our project hello cargo, and Cargo creates its files in a directory of the same name. Go into the hello cargo directory. You'll see Cargo had generated two files, one directory for us and one directory for us, cargo.toml, and a source directory with the main.rs inside. If you had initialized a new Git repository along with git nor file, Git files won't be generated if you run cargo new. With an existing Git repository, you can override this behavior by using cargo new vs equals Git. Open cargo toml to your text editor of choice. It should look similar to the code in. Okay. Sure. I guess I should open this in VS Code now, because I don't know. I mean, I guess I could open it in Atom, but if I'm going to open a folder anyways, I might as well. Let's see, Rust projects, hello cargo, select. What did I change in here? I don't think anything important, so don't save. That was the voting stuff. Yep. Hello cargo version 01. Yep. This edition, I don't know what this refers to, so let's see. Yep. Tom's obvious minimal language format. First line package is a section heading that indicates that the following statements are configuring a package. As we add more info to this file, we'll add other sections. The next 3 lines are configuration information cargo needs to compile your program, the name, version, edition of Rust to use. Oh, I see. Okay. We talk about edition key in Appendix E. Okay. Maybe later. The last line, dependencies, is the start of the section for E to list any of the project's dependencies, and Rust packages of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in chapter 2, so we'll use this dependency section then. Now open source main.rs. Yep. There's hello world. Cargo has generated hello world, just like the one we wrote. So far, the differences between our previous project and project Cargo generated are that Cargo placed the code in a source directory, and we have a cargo.toml configuration file in the top directory. Cargo expects your source files to live inside the source directory. The top level project directory is just for README files, license information, configuration files, and anything else that's not related to your code. Using Cargo helps you organize your project. There's a place where everything and everything is in its place. If you start a project that doesn't use Cargo, as we did with the Hello World project, you can convert it into a project that does use Cargo, move the project code into the source directory, and create the appropriate cargo.toml file. Build and run the Cargo project. Now let's look what's different when we build and run the Hello World program with Cargo. Okay, so let's just run cargo build, and it's finished. This command creates an executable file in the target debug hello cargo. Okay, so let's try this new fancy -b. So we can cd into target, and then we can do B, okay, and then cd into debug, and then -b, and then there's hello cargo exe, hello world. Okay, notice that this time we didn't see the output indicating that Cargo had compiled hello cargo. Oh wait. Okay, here we go. Yeah, if all goes, let's see. So yeah, this command creates an executable file in this location. You can run the executable with this command. If all goes well, hello world should print the terminal. Cargo build for the first time also causes Cargo to create a new file on the top level called cargo lock. This file keeps track of the exact version of the dependencies in your project. This project doesn't have any dependencies, so the file is a bit sparse. You won't ever need to change the file manually. Cargo manages its contents for you. And just build a project with cargo build and ran it. Okay. so I wasn't following directions. Running cargo build. Okay. Yeah. So okay, sorry. I forgot what I was doing. Okay, so yeah. I was in the root, ran cargo build, then went in and ran hello cargo. And now we can use cargo run to compile the code and run the resulting executable all in one command. So I can do that here, right? Cargo run. Yeah. And it does that. Notice this time we didn't see an output indicating that cargo compiled hello cargo. Yeah, you're right. It says compiling hello cargo. Here it says finished, and then it says running. Yep. Because cargo figured out that the file hadn't changed, so it ran the binary. If you had modified your source code, cargo would have rebuilt. So if I put hello Twitch, save that, go to the terminal and do cargo run, it compiles, finishes running, and hello Twitch. Nice. Okay. Let's see. And then you can do cargo check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. Why would you not want an executable? Often cargo check is much faster in cargo build because it skips the step of producing an executable. If you're continually checking your work while writing the code, using cargo check will speed up the process. As such, many Rust stations run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Okay, so I don't think I need to read the recap. When your project is ready for release, you can do cargo build back release, and then to compile with optimizations, this command will create an executable in target release. So cd target c okay. It takes, yeah, the optimizations make your Rust code run faster, but turning them on lengthens the time it takes for the program to compile. This is why there are two different profiles, one for development and the other one when you want to rebuild quickly and often, another for building the final program you'll give to your users that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's runtime, be sure to run cargo build release, the benchmark, with the executable, and okay, should be fast. Cargo as convention. With this simple project, cargo doesn't provide a lot of value just using Rust C, but it proves its worth as your programs become more intricate with complex projects composed of multiple crates. It's much easier to let cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing project, you can use the following command to check out the code using git change to the project's directory and build. Okay. I mean, yeah, that's cool. Kind of expected these days, I think. Yeah. All right. Chapter 2, the guessing game. This is one long chapter. Okay, programming a guessing game. Let's jump into Rust by working on a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match methods, associated functions, using external crates, and more. In the following chapter, we'll explore these ideas in more detail. In this chapter, you'll practice the fundamentals. We'll implement a classic beginner program problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. It will prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too high or too low. If the guess is correct, the game will print a congratulatory message and exit, setting up the new program. Okay, so let's see. I don't know. This is how I normally use terminal. I probably look like an idiot, honestly, because I know there are people who are like terminal geniuses. I don't know. New guessing game. Yep. And then we'll go inside. Yep. Okay. Yep. We use cargo new, and then let's open folder. Yeah. All right. Yep. And that's the guessing game. Okay. Take a look at the toml. Looks normal. Okay. Look at the main. Looks good. I'm not going to compile it because cargo run. That's all you're doing. Okay, processing a guess. The first part of the guessing game program will ask for users' input, process the input, and check that the input is in the expected form. To start, we'll allow the player to input a guess, enter code. Okay, so here, let's see. Yep. So print line, we'll see here. Guess the number, exclamation point. So we'll print line, and then we'll please input your guess. Okay. And then here they do a let mutable guess equals string new. Yep. And then IO. Oh, yep. I already am not even copying this right because they add a IO. Okay. Yep. And then stdin. I guess. Oh, I forgot the. See, that is gonna that's gonna get me every time. I am just not used to that. Yep. And then here I'm going to do and moot guess, and then dot expect expect relative line, and then this is fairly complicated. We got my semicolon here, and then print line you guessed. Okay, and then comma guess. Yep. Okay. So let me guess what this does. I mean, it's fairly straightforward. So you create a mutable string, new string called guess, and then here you import the IO library and use this function called stdin, which I assume allows you to read from the command line, and then you read line this mutable guess. See, and I'm not so great with pointers and stuff. I guess, this and I assume means it's pointing to this guess. I am not a great I'm not great at this pointer stuff. So dot expect failed to read line. Expect. So it's weird it's called expect. I would expect it to say accept. Expect. Yeah. So if it's not what you're expecting, then I'm guessing that's like the mentality behind it. So, yeah. Yep. So this code contains a lot of information. So let's go over it line by line. To obtain user input and then print the results as output, we need to bring the IO input output library into scope. The IO library comes from the standard library known as std, the standard library, stdio. Yep. By default, Rust has a few items defined in the standard library that it brings into scope for every program. This set is called the prelude, and you can see everything in the standard library, everything in it in this documentation. If a type you want to use is in the prelude, you have to bring that type into scope explicitly with a use statement. Using the stdio library provides you with a number of useful features, including the ability to accept user input. As you saw in Chapter 1, the main function is the entry point into the program. The fn syntax declares a new function. The parentheses indicates there's no parameters, and the curly bracket starts the body of the function. As you learned in Chapter 1, print line is a macro that prints a string to the screen. This code is printing a prompt stating that what the game is and requesting a user to input. Next, we'll create a variable to store the user input like this. Okay, and now the program is getting interesting. There's a lot going on in this line. We use let statement to create a variable. Yes, so apples 5. This line creates a new variable called apples. This is kind of like JavaScript these days. It has a lot of lets in it. And binds it to the value 5. In Rust, variables are immutable by default. We'll be discussing these concepts in detail in the variables immutability section in Chapter 3. To make variables mutable, we add mute before the variable name. So mutable just means that you can change it. This you cannot change. This you can change. So, and by default, this is a security thing. You can't change these values. That's because a lot of times being able to change these values can cause bugs in your program. So if you're forced to indicate that a value is going to change, then there's less risk that something that's not supposed to change changes. Let's see, that's comments. Cool. Returning I'm a particular fan of the hashtag as a comment, but backslash is fine too. Or that's //. Yep. Oh, where's the /? Okay, it's question mark. Yep. Returning to the guessing game program, know that let mute guess will introduce a mutable variable named guess. The equal sign tells Rust we want to bind something to the variable now. On the right of the equal sign, the variable that guess is bound to, which which is the result of calling string new, a function that returns a new instance of a string. String is a string type provided by the standard library that is growable, UTF-8 encoded bit of text. So, that's pretty interesting. This whole growable string type is difficult in these compiled languages, because most of the time you have to know exactly how large or how small arrays are. And technically the string type is probably just an array of characters. And so being able to insert characters and grow the array dynamically is sometimes a difficult thing. But that's very convenient to be able to have a growable string. The ... syntax in the new line indicates that new is an associated function of the string type. An associated function is a function that implements on a type. In the case string, the new function creates a new empty string. You'll find new function on many types because it's a common name for a function that makes a new type of some kind. Yep. So I assume you can integer new, or object new object, right? In full, the let mute guess equals string new line has created a mutable variable that is currently bound to a new empty instance of string woo. Okay. Recall that we included the input-output functionality from the standard library with use standard library IO. In the first line of the program, now we'll be calling stdin function from the IO module, which will allow us to handle user input. If we haven't imported the IO library with use stdio, at the beginning of the program, we could still use the function by writing this function call. So you can call the standard library without the use at the beginning. The stdin function returns an instance of stdio stdin, which is a type that represents a handle to the standard input for your terminal. Next, the line readline and mute guess calls the readline method in the standard input handle to get input from the user. We're also passing and mute guess as an argument to readline to tell it what string to store the user input in. The full job of readline is to take whatever the user types into the standard input and append it into the string without overwriting its contents. So we therefore pass the string as an argument. The string argument needs to be mutable so that the method can change the string's content. The and indicates that the argument is a reference, not pointer, which I mistakenly called this earlier, which gives you a way to let multiple parts of your code access one piece of data without needing to copy the data into memory multiple times. So, okay. So the and allows you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times, right? Right, so I think that's what pointer is. I don't know. So references are a complex feature, and one of Rust's major advantages to how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. For now, all you need to know is that, like variables, references are mutable by default. Hence, you need to write and mute guess rather than and guess to make it mutable. Okay. But you can do and guess to point to this. But we need to, I guess, readline takes whatever the user types and appends it to a string. Which that's readline does more than just read the line, I guess. It reads and copies, or yeah. Hence, you need to, yeah, okay. Handling potential failures with result type. So we're still working on this line of code, although we're now discussing the third line of text. It's still part of a single logical line of code. The next part of is this method. Okay, we could have written this code as IO std and read line. Yeah. However, one long line is difficult to read, so it's best to divide it. It's often wise to introduce a new line and other white space to help break up the long lines when you call a method with the method name syntax. The dot method name syntax. Now let's discuss what this line does. As mentioned earlier, readline puts whatever the user enters into the string that we pass, but it also returns a value, in this case IO result. Okay. Rust has a number of types named result. It is in its standard library a generic result, as well as specific versions for submodules such as IO result. The result types are enumerations, often referred to enums, which can have a fixed set of possibilities known as variants. Enums are also used with match, a conditional that makes it convenient to execute different code based on which variant an enum value is when the condition is evaluated. Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Results variants are OK or error. Okay. The OK variant indicates the operation was successful, and inside OK is a successfully generated value. The error variant means that the operation failed. The ERR contains information about how or why the operation fails. Values to the result type, like values of any type, have methods defined on them. An instance of IO result has the expect method that you can call. If this instance of IO result is an error value, expect will cause the program to crash and display the message that you pass as an argument to expect. If the readline method runs an error, it would likely be the result of an error coming from the underlying operating system. If the instance of IO result is an OK value, expect will take the result value, and OK is holding and return just the value to you so you can use it. In this case, the value is the number of bytes in the user's input. If you don't call expect, expect. Okay, I'm making sure it's expect, because it just feels wrong that it's named this. I don't like the name of this function because it doesn't feel like it does what the name implies. But I guess you just get used to that. The program will compile, but you'll get a warning. Okay, cool. Wait, what? If you don't call expect, so you always have to call expect, or you should call expect. It'll say, if you don't call it, yeah. So you're using readline. Readline returns a result. Result has two different types. Well, result can return OK or error, and both of those objects have texts that come with them, I guess. was what I read. And so, yeah, Rust warns you haven't used result value returned from read line, indicating that the program hasn't handled a possible error, right? So the right way to suppress the warning is actually write error handling, but in our case, we just want to crash the program when the problem occurs, so we can use expect. You'll learn about recovering from errors in Chapter 9. Okay. Aside from the closing curly brace, there's only one more line to discuss in this code so far. This prints the string that now contains the user input curly brace. Set of curly brackets and a placeholder. Think of the curly brace as a little crab pincers, sticking with the rustation theme, that holds a value in place. You can print more than one value using curly brackets. The first set of curly brackets holds the first value list. After the format string, the second holds the second. The second set holds the second value, and so on. Printing multiple values in one call to print line will look like this. Yep. Test the final part. Okay. Testing the first part. So here you go cargo run. And then I will put 10. You guess 10. Yeah. And I guess I should put past tense. Guessed. Okay. Generating a secret number. Next, we'll need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun to play more than once. We'll use random numbers between 1 and 100, so the game isn't too difficult. Rust doesn't include random number functionality in its standard library. However, Rust team does provide a rand crate that with said functionality. Using crate to get more functionality. Remember that crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code intended to be used in other programs and can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before we can write this code using rand, we need to modify the cargo toml file. Okay. Include rand crate as a dependency. Open the file now and add the following line to the bottom beneath dependencies section, header, and cargo that Cargo created for you. Be sure to specify rand exactly here, and with this version number, or the code examples in the tutorial might not work. Okay. Paste. We'll save that. Oh, there's the 385. Cool. In the cargo toml file, everything that follows a header is part of that section that continues until another section starts. In dependencies, you tell Cargo which external crates your project depends on and which versions of the crates you require. In this case, we specify a rand crate with a semantic version specifier 083. Cargo understands semantic versioning, sometimes called semver, which is a standard for writing version numbers. The number 083 is actually shorthand for up 083, which means any version that is at least 083 and below 090, but below 090. Cargo considers these versions to have public API compatible with version 083, and this specific specification ensures you'll get the latest patch release that will still compile with the code in this chapter. Any version 090 or greater is not guaranteed to have the same API as what the following example uses. Now, without changing any code, let's build the project as shown in listing 2.2. Okay. So cargo build. That's a lot of stuff happening. Okay. You may see different version numbers, but they will all be compatible with the code thanks to SEM for different lines depending on the operating system. And the lines may be in different orders. When we include an external dependency, cargo fetches the latest version of everything that dependency needs from the registry, which is a copy of data from crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only list RAND as a dependency, Cargo also grabs other crates that RAND depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. If you immediately run cargo build again without making any changes, you won't get any output aside from the finished line. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply exits. If you open up the source main RS file, making a trivial change and then save it and build it again, you'll only see 2 lines of output. These lines show that Cargo only updates the build when your tiny change to the source main RS file with your tiny change. Your dependencies haven't changed, so Cargo knows it can reuse what it has already downloaded and compile for those. Ensure reproducible builds with the Cargo lock file. Cargo has a mechanism that ensures that you can rebuild the same artifacts every time you or anyone else builds your code. Cargo will use only the version of the dependencies you specify until you indicate otherwise. For example, say the next week's version 0.84 of RAND crate comes out and the version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates a cargo lock file the first time you run cargo build. So now we have this in the guessing game directory. When you build a project for the first time, Cargo figures out all the versions of dependencies and that fit the criteria and then writes them to the cargo lock file. When you build your project in the future, Cargo will see that the cargo lock file exists and use the version specified there, rather than doing all the work to figure out versionings again. So this lets you have a reproducible build automatically. In other words, your project will remain at 0.83 until you explicitly upgrade thanks to cargo lock. Okay. That's fun because I don't know. I mean, I feel like it has to do that. But updating a crate to get a new version. When you do want to update a crate, Cargo provides the command update, which will ignore the cargo lock file and figure out all the latest versions that fit your specification in cargo toml. Cargo will then write those versions to cargo lock file. Otherwise, by default, Cargo will only look for versions greater than 8.3 and less than 9. If the RAND crate has released the 2 new versions, 0.84 and 0.9, you would see the following in the cargo update. Right, because 9 would break it. Cargo ignores the 9 release. At this point, you would also notice a change in the cargo log file, noting that the version of the RAND crate you are now using is 084 to use RAN version 090. Any version of the 09X series, you'll have to update the cargo toml file to look like this instead. The next time you run cargo build, cargo will update the registry of the crates available and reevaluate your RAND requirements according to the new version you have specified. There is a lot more to say about cargo and its ecosystem. We'll discuss that in chapter 14, but for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so REST stations are able to write smaller projects that are assembled from a number of packages. Let's start using RAND to generate numbers to guess. The next step is to update source main rs as shown in listing 2.3. Okay. Yep. So, I guess, yeah, they just add that up here, it looks like. Why would he print the secret number? Okay, I mean, that's fine. I guess you would do it for testing purposes, because you know, you would want to see. Okay. He hasn't created the gen range. That's funny. I'm using okay. We'll see. Let's just read it and see if we can fix this. First, we add the line use ran RNG. The RNG trait defines methods from the random number generator implementation that this trait must scope. Chapter 10 will cover traits in detail. Next, we'll add 2 lines to the module. The first line we'll call ran thread RNG function that gives us a particular random number generator that we're going to use. One that is local to the current thread of execution and seeded by the operating system. Then we call the gen range method on the random number generator. This method is defined by the RNG trait that we brought into scope. Okay. Yep. With the use ran RNG statement, the gen range method takes a range expression as an argument and generates a random number in the range. So I didn't import the use st or rand, right? Yeah. But this one's ran r and g, lowercase, and now it works. Okay, awesome. Yep, that's what I did wrong, because this function didn't exist. Yeah. Okay, good. We call the gen range method on the random number generator. This method is defined by RNG trait that we brought in scope. Yeah, yada, yada. The gen range method takes a range expression as an argument and generates a random number in the range. The kind of range expression we're using here takes the form start.n and is inclusive of the lower bound but exclusive of the upper bound. We need to specify 1 to ... 101, request a number between 1 and 100. Alternatively, we could pass the range 1 ... equals 100, which is equivalent. Okay. No, you won't just know which trait to use and which methods and functions to call from a crate. So each crate has documentation with instructions for using it. Another neat feature of Cargo is running cargo doc open command will build documentation provided by all dependencies locally and open it in your browser. If you're interested in other functionality in the RAN crate, for example, run cargo doc open and click RAN on the sidebar on the left. The second new line prints the secret number. This is useful when we're developing a program to be able to test it, but we'll delete it from the final version. It's not much of a game if the program prints the answers. Yep. So try programming, try running the program a few times. Okay. So let's try that. Let's try running the program a few times. Cargo run. 37. You guessed 37. So I guess it needs to congratulate me. So I guess the next thing would be like if let secret number equals guess. Oh, this needs a semicolon. This needs a print line. Nice noise. Save. Okay, and save that. And can I run it? Ooh, doesn't like that. 60. Nice. This is funny. If let proud. So we'll just screenshot this, I guess. Yeah, that's fine. Okay. All right. Okay, comparing the guess to the secret. Oh yeah, you can do match. Right. Because that comes with the read line, right? I don't know. Maybe. I'll just copy this. Paste. Ooh. I guess I need to declare ordering. Hold on a second. I really need to use the restroom. Put this here. Okay, back. I need to get a away screen or something. I don't know. So, anyways, ordering. I see that he added another library here. I see that he puts the standard IO last, which I haven't done. Mismatched types. Okay. Did I forget to do something from here? Ran threads RNG. So this looks like type annotation needed for integer can't infer type for type integer. So note multiple I don't know what that means. Can't. How do I add a type to this thing? Oh, do I do like integer? Integer. I don't know. But it knows that it's an integer. It's calling it an integer. Right? I don't know. Let's keep reading. Now that we have the user input and a random number, we can compare them. That step is shown in list 2.4. Note that this code won't compile yet, as we will explain. Okay. Fine. Let's read it. First, we add another use statement. Yep, we figured that one out. Ordering into scope from the standard library. The ordering type is another enum that has variance less, greater, and equal. That's fancy. These are the three outcomes that are possible when you compare two values. Yep. When we add 5 new lines at the bottom that use the ordering type, the CMP method compares to the compare method compares two values and can be called on anything that can be compared. Okay. It takes a reference to whatever you want to compare with. Here it's comparing the guess to the secret number. Yes. Guess, match, guess, compare to secret number. Then returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression to decide what to do based on the variant of ordering was returned from the call to compare with the values and guess and secret number. Yes. So match. Yeah, and there are 3 things you can match. Okay. And then, oh yeah, if it matches this arrow here, if it matches, then do this. Match is the thing that you do. You guess dot compare these things. So, and if it matches this, it's less than, then it's too small. Yep. All right. A match expression is made up of arms. An arm consists of a pattern to match against in the code that should be run if the value given to match fits the arm's pattern. Rust takes the value given to match and looks through each arm's pattern in turn. Patterns and the match construct are powerful Rust features that let you express a variety of situations your code might encounter and make sure you handle them all. These features will be covered in detail in 6 and 18 respectively. Yeah, I haven't seen, I mean, I've seen matches. I guess this kind of reminds me of like a switch or something. But I think it's called a switch. I don't know. Again, I'm not a great programmer, but I wish I was. Let's walk through an example with the match expression we use here. Say that the user has guessed 50 and the randomly generated secret number this time is 38. When the code compares 50 to 38, the compare method will return ordering greater because 50 is greater than 38. The match expression gets the ordering greater value and starts checking each arm's pattern. It looks at the first arm and sees the value ordering greater does not match ordering less, so ignores the code in the arm and moves to the next arm's pattern ordering greater, which does match ordering greater. The associated code in the arm will execute and print too big to the screen. The match expression ends because it has no need to look at the last arm in this scenario. However, the code in listing 2-4 won't compile it yet. Let's try. Yes. So the core of the error states that there's a mismatch type. Yes, that makes sense because this is an int and this is a string. Rust has strong static type system. However, it also has type inference. When we wrote let mute guess equals string new, Rust was able to infer that guess should be a string and didn't make us write the type. The secret number, on the other hand, is a number type. A few of Rust's number types can have the value of 1 to 100, an I32, a 32-bit number, a U32, an unsigned 32-bit number, an I64, a 64-bit number, as well as others. Unless otherwise specified, Rust defaults to an I32, which is the type of the secret number. Now, the type of the secret number is technically an unsigned 32 because it can only be a positive integer, right? Unless, but yes, I35, 32 works too. Unless you add type information elsewhere, that would cause Rust to infer a different numerical type. The reason for the error is that Rust cannot compare a string and a number type. Ultimately, we want to convert the string the program reads as input into a real number type, so we can compare it numerically to the secret type. We do so by adding the line in the main function. So you make the string, and then you do the read line, and then you okay, yeah. So you let guess, and that's a U32. It does use a U32. Guess dot trim, yeah, dot parse dot expect. Please try a number. Please try a number, and then end it. And then, yeah, and then you print the line, and then you guess. And that fixes everything. It fixes both this one and that one. Because you convert this into an int. And this one goes away too, which is interesting. Because I guess it knew that this was an integer, but then you compared it to a string, and it was like, I don't know if it's a string or an integer anymore. But then here, when you like actually say that it's a integer, it's like, okay, yeah, everything is okay. We create variable named guess, but wait, doesn't the program already have a variable named guess? It does, but hopefully Rust allows us to shadow the previous value of guess with a new one. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables such as guess string and guess, for example. We'll cover this more detail in chapter 3, but for now, know that this feature is often used when you want to convert a value from one type to another. We bind this new variable to the expression guess.trim.parse because I guess you might have like a bunch of blank space, and then your parse wouldn't work properly. The guess in the expression refers to the original guess variable that contains an input string. The trim method on the string instance will eliminate any white space at the beginning and end, which we must do to be able to compare the string to the U32, which can only contain numerical data. The user must press enter a satisfied read line and input their guess, which also adds a new line character in the string. For example, if you press 5 and press enter, guess will look like 5 backspace n. The backslash n represents new line. On Windows, pressing enter results in a carriage return and a new line. So you get backspace r, backspace n, or backslash. The trim method eliminates new line or return new line results in just returns 5. The parse method on strings parses a string into some kind of number, but this method can parse a variety of number types. We need to tell Rust the exact number type we want to use. Let guess U32, the colon after guess tells Rust will annotate the variable's type. Rust has a few built-in number types. The U32 here is an unsigned 32-bit integer. It's a good default choice for small positive numbers. You'll learn about other number types in chapter 3. Additionally, the U32 annotation is in this example program. And the comparison with secret number means that Rust will infer the secret number should be a U32 as well. So now the comparison will be between two types of the same value, or same type, values of the same type. The parse method will only work on characters that can logically be converted into numbers, and so can easily cause errors. If, for example, the string contains an A, thumbs up, %, there would be no way to convert that to a number because it might fail. The parse method returns the result type, much as the readline method does, discussed in handling potential failures with result type. We'll treat this result the same way by using expect method again. If parse returns an error result variant because it couldn't create a number from the string, the expect call will crash the game and print the message we give it. If parse can successfully convert the string to a number, it will return OK of result, and expect will return the number that we want from the OK value. Cool. Let's run the program now. So cargo run, compile, guessing game, blah, blah, blah. Okay, nice. Even though spaces were added before the guess, the program still figured out that the user gets 676. Run the program a few times to verify the different behaviors with different kinds of input. Guess the number correctly, guess the number too high, guess the number is too low. we have most of the game working, but the user can only make only one guess. Let's change that by adding a loop. And then you can just loop through the guess. Let's see. Then you can loop. It's just called loop, huh? That's fun. I like that. I don't like expect, but I like loop. That's easy to remember. I hate the while. I hate while in Python. While true, I think it's stupid. But loop is fun. As you can see, we've moved everything from the guess input prompt onward into a loop, but be sure to indent the lines inside the loop another 4 spaces each and run the program again. The program will now ask for another guess forever, which actually introduces a problem. It doesn't seem like it can quit. Okay, yeah, that forgot about that. As you can see, we've moved everything from the guess input prompt onward into a loop. Be sure to indent the lines inside the loop another 4 spaces each and run the program again. The program will now ask for another guess forever, which actually, okay, yep. The user could always interrupt the program by using the Control C, but there's another way to escape the insatiable monster as mentioned in the parse discussion. And comparing, yep, if the user enters a non-number answer, the program will crash. Okay, yep. Typing quit will quit the game, as you'll notice. So while entering any non-number input, this is suboptimal to say the least. We want the game to also stop when the correct number is guessed. Let's program the game to quit when the user wins by adding a break statement. So equal you win, and then is that in the, so yeah, here they curly brace this and there's no comma anymore. Curly brace, delete comma, and then enter, and then break. Okay. Adding the break line you win after you win makes the program exit the loop when the user guesses the secret number correctly. Exiting the loop means exiting the program because the loop is the last part of main. Handling invalid input to further refine the game's behavior rather than crashing the program when the user inputs a non-number. Let's make the game ignore a non-number so the user can continue guessing. We can do that by altering the line where guess is converted from a string to U32 as shown in 2.5. Okay. Yes. Okay. So here, yes, instead of expect, what they're doing is putting this curly brace here, and then they're saying okay num, so return the number error underscore continue, and then expect one, oh wait, so here, yeah, so okay, Okay. Yeah. So they turned it into another match. Oh. Yeah. Match is like the if statement. If this, well, if uh, okay, then that's the number. If error, then continue. Yeah. Match instead of if. Is that true? Do they have if here? Control. I guess we'll learn that in the next chapter. We switch from an expect call to a match expression to move from crashing on an error to handling the error. Okay, remember that parse returns a result. Result is an enum that has okay and error. We're using a match expression here, as we did with the ordering result of the compare method. If parse is able to successfully turn the string into a number, then we return an OK value which contains the resulting number. The OK value will match the first arm's pattern, and the match expression will return the number value that the parse produced and put it inside the OK value. The number will end up right where we want it in the new guess variable we're creating. If parse is not able to turn a string into a number, it will return error value that contains more information about the error. The error value does not match the OK number pattern in the first match arm, but it does match the error underscore pattern in the second arm. The underscore is a catch-all value. In this example, we're saying that you want to match all error values no matter what information they have inside of them. So the program will execute the second arm code continue, which tells the program to go to the next iteration of the loop and ask for another guess. So effectively, the program ignores all errors that parse might encounter. Now, everything in the program should work as expected. Let's try. Awesome. With one tiny tweak, we will finish the guessing game. Recall that the program is still printing the secret number. That worked well for testing, but it ruins the game. Let's delete the print. Yeah. Okay. Delete that print. And that outputs the secret. Yep. Summary. At this point, you successfully built a guessing game. Congratulations. This project was a hands-on way to introduce you with many new Rust concepts: let, match, function, the use of external crates, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers the concepts. Well, let's see. Should I move on to chapter 3? That took an hour and a half, and chapter 1 was easy. So chapter 2 wasn't too bad. Chapter 3 seems like it's much longer. Chapter 4 or 5. So we'll just get through it. Let's just read about additions here, because we skipped that, and then we'll start doing, I don't know how many chapters I'll be able to get through tomorrow. I'll at least want to get through 3 and 4, but I would like to do like 10. That might be too crazy. I don't know. Appendix E Editions. In chapter 1, you saw Cargo New adds a bit of metadata to your Cargo TOML file about an addition. This appendix talks about what that means. The Rust language and compiler has a 6-week release cycle, meaning users get a constant stream of new features. Other programming languages release larger changes less often. Rust releases small updates more frequently, after a while, all of these tiny changes add up. But from release to release, it can be difficult to look back and say, wow, between Rust 1.10 and 1.3.1, Rust has changed a lot. Every 2 or 3 years, the Rust team produces a new Rust edition. Each edition brings together the features that are landed into a clear package with a full update documentation and tooling. New editions ship as part of the usual 6-week release process. Editions serve different purposes for different people. For active Rust users, a new edition brings together incremental changes into an easy-to-understand package. For non-users, the new edition signals that some major advancements have landed, which might make Rust worth another look. For other developers, for those developing Rust, a new edition provides a rallying point for the project as a whole. At the time of writing, 3 Rust editions are available: 2015, 2018, 2021. This book is written using Rust 2021. The edition key in cargo toml indicates that these indicates which editions the compiler should use for your code. If key doesn't exist, Rust uses 2015 as the edition value for backwards compatibility reasons. Each project can opt into an edition other than the default 2015 edition. Editions can contain incompatible changes, such as including a new key that conflicts with identifiers in code. However, unless you opt into these changes, your code will continue to compile even as you upgrade the Rust compiler version you use. All Rust compiler versions support any edition that exists prior to the compiler's release, and they can link crates to any supported edition together. Edition changes only affect the way compiler initially parse code. Therefore, if you're using Rust 15, and one of your dependencies uses Rust 2018, your project will compile and use that dependency. The opposite situation where your project uses 2018 and a dependency uses 2015 works as well. To be clear, most features will be available in all editions. Developers use any Rust edition will continue to see improvements as new stable releases are made. However, in some cases, mainly when new keywords are added, some new features might only be available on later editions. You will need to switch editions if you want to take advantage of such features. For more details, the edition guide is a complete book about editions that enumerates the differences between editions and explain how to automatically upgrade your code to a new edition via cargo fix. Oh, that's fun. Yeah. Okay. So that's a lot of reading. But we can go on to chapter 3. I need to learn about mutability. Maybe. No, I'm thinking of references again. I was confused. In C, pointers, and I always confuse the and the asterisks in C. I could never do it. I would always forget if it was mutable or if it was a pointer. Here, I guess, is an indicator if it's mutable, and if it's a reference, then it uses I don't know. I guess there's no reference anymore. Wait, is it? No. Yeah. This is a reference, or this is called shadowing. This is a reference. It's a secret, right? But this is mutable. Yeah, that's gonna confuse me a lot. I think. I better, let's just double check this real quick. Let's see. Reference. Oh god. Okay. And indicates that the argument is a reference. Yes. But, you know, you also put and in front of mutable. So that's confusing for some people. I don't know. Again, maybe I'm just stupid. But this is more clear to me than asterisk versus and sign. Yeah. And I think, yeah, I don't know. It's been a minute since I've programmed in C. It's been a few years for me. But I liked it. I thought it was fun. But this feels a lot better. I like the loop. I like loops. I don't like match so much. It feels weird coming because my intuition is to put an if statement here. So that's going to be something to get used to. Because yeah. But this does look a lot cleaner and it makes sense to have the match, and then you put your things that you want to match in here and what your outcomes are, like that, in a list. It's nice. This, was unintuitive to me, changing this into a if statement that way. But yeah, no, it makes sense. And then the type thing. Can I do U32 like that too, right? Yeah. Okay. Yep. So it's kind of late, so I'm going to hang up the stream. But oops. That's not what I wanted to do. Yeah, it's real late. Okay. I'll see you guys.